Welcome to this presentation on mandatory access control. Here we will discuss system-enforced access controls like Security Enhanced Linux and AppArmor. Mandatory access control, often called MAC, is a security model where the access policy is determined by the system and not by the owner of the resources. Here are some key aspects of MAC. First, system-wide policies are enforced by the operating system. Second, access decisions are based on security labels. Third, users cannot override security policies. Fourth, there is centralized administration of security. Let's compare mandatory access control with discretionary access control, often called DAC. In MAC, the system enforces access policies, whereas in DAC, resource owners control access. In MAC, users cannot modify security settings, whereas in DAC, users can modify permissions. MAC is based on security labels and clearances. DAC is based on user identity and groups. MAC has centralized administration, while DAC has distributed administration. MAC provides higher security but lower flexibility, whereas DAC offers lower security but higher flexibility. Examples of MAC include Security Enhanced Linux and AppArmor. Examples of DAC include Unix permissions and access control lists. Now let's introduce Security Enhanced Linux, often called SELinux, which is a security architecture integrated into the Linux kernel that provides mandatory access control mechanisms. Security Enhanced Linux was developed by the National Security Agency and released as open source. It implements type enforcement security model. It controls access based on security contexts and operates independently of traditional Unix permissions. Security Enhanced Linux is the default in Red Hat, Fedora, and CentOS distributions. To check the Security Enhanced Linux status, use the getenforce command. To view Security Enhanced Linux context of a file, use the lsz command. Let's explore Security Enhanced Linux security contexts. A typical context string looks like this: user_u:_r:type_t:_s0. The first part, user_u, represents the Security Enhanced Linux user identity, which is separate from Linux user accounts. The second part, role_r, is the role-based access control component that links users to domains. The third part, type_t, is the most important field, which defines the domain for processes and the type for files. The last part, S0, represents multi-level security sensitivity level and categories. As an example, to view the process context, use the psz command. To view the file context, use the lsz command followed by the file path. Security Enhanced Linux has 3 operating modes: enforcing, permissive, and disabled. In enforcing mode, the Security Enhanced Linux policy is enforced. Access denied by the policy is blocked and logged. To set Security Enhanced Linux to enforcing mode, use the command sudo setenforce1. To make this setting permanent, edit the Security Enhanced Linux configuration file. In permissive mode, the Security Enhanced Linux policy is not enforced, but violations are logged. This mode is used for troubleshooting. To set Security Enhanced Linux to permissive mode, use the command sudo setenforce0. To make this setting permanent, edit the Security Enhanced Linux configuration file. In disabled mode, Security Enhanced Linux is completely disabled. No policy is loaded, and no logging of violations occurs. To disable Security Enhanced Linux, edit the Security Enhanced Linux configuration file. Note that disabling Security Enhanced Linux requires a reboot. Now let's discuss AppArmor. AppArmor is a Linux security module that restricts programs' capabilities with per-program profiles. It is a path-based access control system and is the default in Ubuntu and SUSE Linux. It is simpler to configure than Security Enhanced Linux and uses profiles to define application permissions. It focuses on application confinement rather than system-wide policy. To check application armor status, use the command sudo aa status. AppArmor Profiles define the security settings for individual applications. A profile includes the path to the confined program, file access rules, network access controls, capability restrictions, and resource limits. AppArmor has two profile modes: Enforce mode, which blocks unauthorized actions, and Complain mode, which logs violations but allows actions. AppArmor profiles are stored in the /etc/AppArmor d/directory and are named after the path of the binary they confine. Here is an example of an AppArmor profile for Firefox. Here is a comparison of AppArmor and Security Enhanced Linux. AppArmor uses path-based access control, while Security Enhanced Linux uses label-based access control. AppArmor has simpler, text-based profiles, while Security Enhanced Linux has a more complex policy language. AppArmor has a lower learning curve, making it easier to learn and configure, while Security Enhanced Linux has a steeper learning curve, making it more complex to master. AppArmor is the default in Ubuntu and SUSE Linux, while Security Enhanced Linux is the default in Red Hat, Fedora, and CentOS. AppArmor focuses on application confinement, while Security Enhanced Linux focuses on system-wide security policy. AppArmor provides less granular control, while Security Enhanced Linux provides more granular, fine-grained control. Here are some best practices for implementing mandatory access control effectively in your environment. First, start in permissive mode to identify potential issues before enforcing policies. Second, monitor audit logs regularly to identify policy violations and refine rules. Third, test applications thoroughly in development environments before deploying Mac policies to production. Fourth, implement Mac incrementally by applying it to critical systems first, and then gradually expanding coverage. Fifth, document all Mac policies, exceptions, and customizations clearly. Sixth, use available tools like AAGenProf for AppArmor or Audit to allow for Security Enhanced Linux to generate policies. Mandatory access control provides a powerful layer of security when implemented correctly. Choose the solution that best fits your environment's needs and security requirements. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.